Okay, I'm going to try to explain in this video how we do vectors and some of the important things that you need to be able to do for this highest level topic. Okay, so a vector is a way of navigating your way around shapes. Okay, we start with the basic vector. Let's go from O to A. We can call that vector lowercase a. Yes. So that is a distance from O to A, and it's also a direction. It's pointing in that direction going upwards. Okay, so a vector's definition is that it has magnitude, distance, and a direction as well. So that's vector A, and vector B might be going from the origin O to this point B here. Okay, that's our starting point. This is a parallelogram, so all of these lengths are exactly the same and they're parallel. So we're going to try to navigate our way around the shape and try to get to point D over here. Okay, so to get from O to D, I could go O to A using that vector, and then I could go along A to D. So O to A, A to D. I like to write it out just like this at first to get used to sort of how we're going around the shape. So O to A is vector A, and A to D, well, this would be B, would get me into the middle, and then I'd need another B to get me to the edge here. So it's a B and another B, essentially A plus 2B. Okay, so using our combinations of vectors, we can't go directly from O to D, but we can use the vectors A, B, and B to get there kind of indirectly, going another path. Okay, and it doesn't matter which path I choose. I could have gone B, B, and A. That would still be the exact same thing. Okay, the order doesn't matter, but the signs, they do matter. Because if I go in the opposite direction, it becomes a negative. So minus A would be going kind of that way. Minus B would be going that way. So the signs and the direction are important. You must include those when you're trying to navigate around the shape. Just as an example, I'm going to go a completely different direction. I'm going to go kind of this way, and then down, and go a different path. It would be A, and another A, and then a B and a B would get me to there. And then I'm going to go this way. That is minus A. Okay, so we went A, B, B, and then minus A to go in the opposite direction. And when I collect that all together, that's still A plus 2B, because one of the A's cancels out with the minus A. So we can choose the direction and path that we take. We'll still get the same answer. You just want to go the quickest way and be the most efficient in the exam. So that's the first thing. How about getting to this point here? I'm going to call that M, which is the midpoint of C to D. Okay, so we talk about this kind of midpoint with vectors. I want to go from O to M. Okay, so let's write down our full journey. O to M, I'm going to go O to C, and then C to M. So O to C, C to M. So that's the path using the vectors that I have available to me. O to C, that's going to be two lots of B, B and then B. And then C to M is half C to D. That's what we kind of were told in the question. M is the midpoint, so M is halfway between C and D. So halfway of C to D which is the vector A. So it's a half A, half the distance of A. And we usually write them this way around, like half A plus 2B. We usually do them in alphabetical order. Okay, it's not a big deal, but that's kind of how we do it. All right, so that O to M would get us from here to here, but I can't go direct. I have to use the vectors to get there. Okay, another concept that we need to be aware of for this topic is I'm going to do a point E, and let's call that point X. In the exam, they do stuff like this. dx to xe is in the ratio of 1 to 3. Okay, and what that's saying is that the distance from d to x is 1, x to e is 3, and with our ratio work, we must add these together to have a total of 4 pieces. D to x is a quarter of the distance, and xe is 3/4 of the distance. Okay, so we add up the ratios and we divide. So that's the divide by 4, and we times 1 for dx and we times 3 for xe. So that helps us to turn the ratios into a fraction, because we need that when we're navigating our way around the shape. Because if I want to go from O to X now, O to X would be O to C plus C to D plus D to X, like that. So I've just sort of broken it down a little bit so we can see the individual steps. So O to C was 2 B's, C to D was an A, and D to X was 1/4 of D to E. Let me just zoom out a little bit so we can see that. Okay, so D to X is 1/4 of the total distance D to E, and D to E is just the vector A. So 1/4 A there, like this. D to E was an A, and D to X is 1/4 of that distance. So using the ratios and turning them into fractions with the vectors is one of the difficult parts of navigating our way around the shapes when we're using the ratios as well. We collect this all together. How do we add A plus 1/4 A? This is another part of the curriculum that students don't like and that is introduced into vectors, which is fractions. How do I add A plus 1/4 A? Well, I need a common denominator, quarters, 4/4 is a whole. Okay, so 1A, 1/1 plus 1/4 is essentially what we're doing. If you forget the A for a minute, we're doing a whole number plus 1/4. So if I change the denominators into 4s by timesing by 4, I have to do the same to the top, and I've got 4/4. So this will be 5/4 A, now that I've got that common denominator. So adding a whole number to a fraction is another part of this topic, which has nothing to do with vectors, like ratios, nothing to do with vectors, but they put them together and make this into a difficult topic at the end. Okay, there's one other concept that we need to be aware of when we're dealing with these vectors, and that's the concept of a parallel line. Okay, so I'm going to go from O to T, which is in the middle. O to T is O to A plus A to T, which is O to A, the vector A, and A to T is the vector B. Okay, so if you imagine that line going straight there, it would look like that. That is the vector A plus B. And I just want to point out the ratios of A's to B's is 1 to 1 in this case. Okay, 1a plus 1b. They're in a ratio of 1 to 1. Okay. If I did the same for O to E, 2 A's plus 2 B's, when you look at this ratio of A's to B's is 2 to 2, which we can simplify down to 1 to 1. That line is parallel to O to T. Or if we chose another one, B to D, that would be A plus B as well. Okay, those two lines are parallel to each other because they have the same ratios of A's to B's. That means they are parallel. Okay, if we looked at one of our other vectors like O to X like this is not parallel to either of these two because the ratios of A's to B's is not 1 to 1. Okay, it's something completely different. So that means that they're not parallel to each other. So if you want to show that something parallel, you can either do them as ratios and show that they're the same, or some people prefer to take a 2 out as a factor, and then we have 2 lots of A plus B. So it's the exact same vector, but just twice as big. A plus B is twice. Okay, so this idea of the parallel line is something that you really need to understand for the vectors proofs. And to show that something's a straight line, we go from O to T, T to E, and show that they're parallel to each other. That's how you prove that you have a straight line. So you pick a point along that line, go to there, go from there to the end, and then if they're parallel to each other, that's a straight line. If you went O to T and T to there or something, it would not be a straight line because they're not parallel to each other after the O to T and T to like F or something. You can see that that's not a straight line because the gradients would be different, the ratios of the A's to B's would be different. And that's essentially the knowledge that you need for this topic.